Welcome to The Explainer. Today, we're going to distill the massive legal and real-world implications of blockchain technology, and we are going to do it in just 8 minutes. Now, this isn't just about cryptocurrency prices going up and down. No, this is about a fundamental collision between cutting-edge, decentralized computer code and the foundational laws that actually govern our society. So, let's get right into it.
To help us navigate this incredibly complex landscape, we're drawing from a fascinating academic deep dive by Muharem Kianieff called Blockchain Technology and the Law. We're going to look right past all the crypto hype and the financial bubbles. Instead, we want to examine the inevitable clash between a technology that was literally designed to operate outside of government control and the existing legal systems that have protected consumers for centuries.
Here is our roadmap for today. We'll be hitting 1. Solving the trust problem. 2. Smart contracts and frictions. 3. The code is law myth. 4. Privacy versus immutability. And finally, 5. Merging code with law.
Part 1. Solving the trust problem.
Okay, so what is a blockchain? At its core, it's an immutable, distributed online registry that records transactions across a peer-to-peer network. And I really want to emphasize those two words, immutable and distributed. Because when Satoshi Nakamoto published the famous Bitcoin white paper back in 2008, the whole vision was to create a system where absolutely no single entity, no bank, no government, no massive corporation, controls the ledger. Once the data goes in, it cannot be secretly altered, period.
And this shift, it completely rewires how we transact. Think about the old intermediary model. You want to send money, so a central bank sits in the middle, they verify the transaction, and of course they take a fee. But in the blockchain model, it's totally different. Decentralized computers, which are known as nodes, are distributed all over the world. They race to verify and encrypt that transaction cryptographically. So the middleman is completely removed, and trust is placed in mathematics and network consensus instead of a single corporation.
But listen, this technology is about far more than just Bitcoin. By removing those intermediaries, we massively reduce friction. For example, look at remittance apps like Abra. They can drastically lower international transfer fees just by allowing peer-to-peer asset movement. This exact same ledger concept can be used to track the provenance of goods in incredibly complex supply chains or to definitively secure government identity documents. If it's applied correctly, this tech could radically reduce overall economic transaction costs across the entire globe.
Which brings us to Part 2, Smart Contracts and Frictions.
So a smart contract is basically a computerized transaction protocol designed to automatically execute terms without any intermediaries. Developers use open-source programming to create contracts that essentially enforce themselves. They often rely on outside data sources, what they call oracles, to know when a specific condition is met. If X happens, then Y is automatically paid out or executed. No judges, no lawyers, just pure code.
But here is where that rigid automation hits reality, and it hits hard. Imagine a smart contract linked to your car loan. What if an automated program shuts down your car engine right in the middle of heavy traffic just because an oracle reported a missed payment? The code doesn't know if you're rushing to the hospital in a medical emergency, right? We're also seeing this rigid automation creeping into consumer goods. Take BMW, for instance, controversially trying to charge annual subscription fees just to use basic built-in hardware like Apple CarPlay. The bottom line? Code totally lacks human context and flexibility.
Part 3. The code is law myth.
We are facing a massive paradigm clash right now. On one side, you have the libertarian vision of the early blockchain adopters, this idea that code is law, absolute immutability, zero interference from intermediaries. But on the other side, we have centuries of established commercial law that's built on equity, fairness, consumer protection, and ultimately reducing transaction costs through predictable legal standards.
The real danger of relying solely on code was exposed so dramatically during the DAO attack. The decentralized autonomous organization was this massive, investor-directed venture capital fund run entirely on smart contracts. But, well, the code had a flaw, and a hacker drained millions and millions of dollars. Because the community rejected traditional legal dispute resolution, developers were forced into this messy, highly controversial hard fork, literally splitting the blockchain in two just to correct the error. Code, it turns out, is definitely not flawless.
So the crucial takeaway here is that ignoring existing commercial law actually backfires. It creates totally unpredictable loss allocation when things go wrong.
It forces software developers to essentially reinvent systems of justice completely from scratch. And all this legal uncertainty, it drastically increases transaction costs and risk for businesses. Ultimately, this rigid adherence to code is law severely hinders the long-term mainstream acceptability of blockchain. To actually succeed, new tech has to lower transaction costs, not raise them with a bunch of uncertainty.
Part 4. Privacy versus immutability.
I want you to just think about this for a second. How do you apply the right to be forgotten to a ledger that literally cannot be erased? This is a massive, structural conflict between immutable blockchain technology and strict modern privacy laws. We're talking specifically about the European Union's GDPR regulations, which give consumers the explicit right to have their personal data deleted.
The contrast here is pretty stark. Traditional banking is centralized and it's reversible. If a bank needs to delete your data to comply with privacy laws or report suspicious activity for anti-money laundering compliance, they can do it easily. Blockchain, on the other hand, is decentralized, permanent, and pseudonymous. You can't just call up customer service to delete an entry on a public ledger. This makes regulatory compliance incredibly difficult, if not flat out impossible in its pure form.
And honestly, this immutability builds into a massive security risk, because the pseudonymity of blockchain is largely an illusion. Take the New York taxi data breach as a perfect example. A data scientist took supposedly anonymous taxi records and cross-referenced indirect identifiers, things like pickup times, dates, and locations, with paparazzi photos of celebrities getting into cabs. He was able to unmask exact identities, drop-off locations, and even driver incomes. On a permanent blockchain, your data is just sitting there forever, waiting to be cross-referenced, or worse, waiting for the day quantum computing becomes powerful enough to instantly crack today's encryption.
Part 5. Merging code with law.
So what is the path forward? For blockchain to achieve true mass adoption, developers cannot act as isolated vigilantes. They absolutely must collaborate with legal experts to integrate this tech into existing commercial law. They need to build privacy by design directly into the code from the very beginning, ensuring features can actually adapt to regulations like the GDPR. By prioritizing legal certainty and predictability, they can fulfill the true economic promise of blockchain, which is actually lowering transaction costs for consumers and businesses alike.
This technology has immense potential, but the rule of code will never entirely replace the rule of law. The future isn't about replacing our legal systems, it's about a thoughtful, secure merger of the two. Will developers finally accept the rule of law, or will stubborn code eventually regulate itself right out of existence? If you enjoyed this, subscribe to In 8 Minutes and never miss what matters.